For this week's lab, we'll be looking at lipids and proteins. Uh, the biggest lab technique we'll be using for this experiment is called an extraction. So the idea of an extraction is using a solvent to separate a substance from another mixture. So we're bringing back the concept like dissolves like. In this case, a solvent that should only dissolve a like solute with similar polarity. Example might be like a polar solvent that would wash away a polar salt, or like a nonpolar solvent that would wash away a nonpolar oil. A real life example could be like salt extraction on carpets. So road salt and ice melt, we use that to keep roads and sidewalks from freezing. However, that salt usually ends up staining carpets. So to clean that, to clean the polar salt, we would use a polar solvent, possibly like water. We'd use that to remove the salt without affecting the carpet. Another example of extraction is making coffee. So caffeine that's fairly soluble in hot water, and also eating coffee beans isn't the most pleasant way to take in caffeine. So most people perform an extraction with hot water, separate the caffeine from the coffee beans. So for this lab, we'll be performing an extraction of potato chips. Petroleum ether, that's a nonpolar solvent that we'll use. It should wash away all of the oil and separate the oil from all of the other ingredients. So it should leave behind the potato starch, which is the carbs, the salt, and the protein. So petroleum ether, that's also able to evaporate completely, so it should leave behind only the oil and not contribute any weight to the oil once it's all gone. And then for the calculations, we'll be weighing the separated oil and we'll be weighing the mixture of everything else. So the mixture of everything else that was left behind after the oil is removed, that will be made up of the carbohydrates, the protein, and the salt content. And for the worksheet, we'll call that the uncorrected carbohydrate weight. So in the calculations, we'll have to find the mass of the protein and we'll have to find the mass of the salt and subtract those from the total mass. And that will be considered the corrected carbohydrate mass. And I'll show you how to do that at the end of the lecture. But here I have the nutrition facts from a random potato chip bag. So one serving is 1 ounce or 28 grams. And in a single serving, there's 10 grams of fat, there's 15 grams of carbs, 2 grams of protein, and 170 milligrams of sodium. So here I have all the calculations for all the different macronutrients, even though not all of them are needed for the worksheet. But I think it's important to be able to do this math because it's very relevant to dieting. So if you're able to track your macros, that's pretty much half the battle when you're planning a healthy diet. So you just get these conversion factors from a nutrition label, you multiply by the actual amount of food you have, and then you can find out how much fat is in the amount of food that you have, how much carbs are in the amount of food that you have, how much protein. Or you can just punch it all into MyFitnessPal and do it that way. So anyways, I have 5-gram potato chip sample, and I want to know how much protein there is in that 5-gram sample. So here I take grams of chips times this conversion factor, which comes straight from the label, and that should give me the protein content. And I set this up to make sure that grams of chips cancels with grams of chips. And this will vary depending on the actual mass that you use. But this conversion factor, that should be a constant for the food that you have. So that's the conversion factor always stays the same, but the actual amount of food that you have can change. The other mass that we need to calculate is the mass of salt that was actually in the 5-gram sample. So when they report sodium on a nutrition label, that's actually only the mass of the element of sodium. but when they add sodium to food, they add it in the form of sodium chloride, which is table salt. So in this calculation, we need to first find out how much mass sodium contributes to sodium chloride. So that sounds a little confusing, but just follow along and we should be okay. So first, we need to find the molar mass of sodium chloride, and chemical formula of sodium chloride is just NaCl. So we have the mass of 1 sodium, and we have the mass of 1 chlorine, and so that add those together, and we should get the total mass of sodium chloride. And then we want to find the weight of sodium that contributes to the mass of sodium chloride. So that's pretty much just finding a part divided by the whole. So in this case, sodium is the part, sodium chloride is the whole, and we just do 22.99 divided by 58.44, and that's roughly 40%. So sodium chloride is roughly 40% sodium by mass. So what that means is if we see a nutrition label and it says 40 milligrams of sodium per serving, that means they added 100 milligrams of sodium chloride. So what we need to do is we need to find how much sodium how much sodium chloride there was in our original 5-gram sample. I think the easiest way to calculate that is to use this number here as our conversion factor. So we want to find out how much sodium chloride there is in 1 serving by starting with only the amount of sodium. So here we have only the amount of sodium, and then we want to multiply that by the conversion factor, and I'm making sure that the milligrams of sodium cancels with the milligrams of sodium. We end up with 425 milligrams of sodium chloride, or if we want to convert that to grams, 0.425 grams of salt per serving. So we're concerned with, what we're concerned with is the mass of sodium chloride we originally had. So we would multiply our mass sample times that conversion factor, which is 0.425 grams of salt per serving of chips, and then that should equal our theoretical salt content. And then, so finally we can find the corrected carbohydrate weight. So we'll take the uncorrected carbohydrate weight, subtract that from the salt content that we calculated and the protein content that we calculated, and that should give us the corrected carbohydrate mass. And then, so for the Spec 20 data, this data it's mostly a qualitative test. If there is protein present in the solid after extraction, so the presence of protein that changes the color of the Bradford reagent, and therefore changes the wavelengths of light the solution absorbs. So this change, we can detect that with the Spec 20. And we can just confirm that there is protein in the solution.